Welcome back. Now, as I mentioned at the end of the previous video that we would learn to work out a few math problems. When I said few, I literally mean it. We're only going to do two. And I think I'll have you do a couple through the lab. So two is probably enough. And that's probably all the time I want to spend on this particular video. With that said, I also mentioned the idea of pattern in chemistry. As much as logical reasoning is important, if you wake me up in the middle of the night and had me write a titration problem, I probably would actually, if I were to dictate this problem orally, I probably would just say it the same way. Because I'm trained to write a problem technically in only one way. Okay? And that because writing that one way has a meaning. Because I would not confuse an audience who were taught previously a certain way. So no matter how many times, how many titration problems I would write, I would always use certain words in certain order and write it in certain fashion. Right, now let's take a look at this first problem where it says if 20 milliliter of 0.1 molar HCl was titrated with 0.2 molar sodium hydroxide, what is the equivalence point volume? What we're really saying is, where do we expect to see the equivalence point as we begin to add sodium hydroxide into our acid? Now I have balanced this equation and I know my acid and base are in 1-to-1 ratio, right? Now there is a generic acid-base formulae, and that is volume of acid multiplied by concentration of acid equals volume of base times concentration of base. Now this equation will be provided in your appendix on the exam. You do not have to memorize. Now you would have to use the equation as it is without much changes if the acid and base are in 1-to-1 ratio. Now you do not even have to convert milliliters to liters or molarity to something else, just plug it and chug. So we know the volume of acids 20 mil. We know concentration of acids 0.1 molar. We know volume of base, we don't know, that's what we're trying to find. And then we know the concentration of base is 0.2 molar. Now the reason I said it's a simple plug-in chug, simply because these two are in 1-to-1 ratio. So if you do that, it's 20 times 0.1 over 0.2. So you need 10 milliliters of base to achieve equivalence point. You could actually figure this out and do the titration and figure out if you actually end up getting 10 as an answer. More likely it's always going to be in the ballpark, it's not going to be a 10. Now that's how you do whether it's strong acid, weak base, or any of those combinations I told you, the idea of just figuring out the equivalence point volume is always the same. Now along these lines, I could give you the equivalence point volume and have you find something else, but the formula is the same, so I always give you 3 out of 4 and you figure out. All right, what if you go to this one? Now you'll be tempted, say, oh, it's the same formula, I'm going to use it. You're partially right in making that judgment, but if you notice, I didn't balance the equation. It's an acid-base titration. If you notice, I'll give you the equation as well. You see there's a 2. The reason being, people creating standardized exam don't prey on this top problem. They always prey on the bottom one because most people don't recognize that these are not in 1-to-1 ratio. Now if you actually balance, you notice there's a 2 in front of the NaOH and 2 in front of water. But what we're really interested in is this. So the acid is 1 and the base is 2. So the base takes 2 times the base to react with 1 times the acid. So when you have a problem where your base is 2, acid's 1, you write the generic formulae and multiply the acid side by 2. So if your acid contains 2 and your base is 1, then you multiply the base side by 2. Okay, don't try too hard to do this. Okay, it's very simple. Don't make it hard on yourself. Whichever side is 2, the base is 2, multiply the acid side by 2. If the acid is 2, multiply, or 3 or 4, whatever be it, multiply the base side by that. Right? So in this case, the base is 2, so I multiplied the 2 on the acid side. We know everything else, so 2 times volume of acid is 20 mils. 20 mil times concentration of acid is 0.1. We don't know volume of base. We know concentration of base is 0.2 molar. Right? So it'll be, if you notice, 2 times 20 times 0.1 divided by 0.2. What do you see is different? Well, the numbers are exactly the same, but you see, comparing the volume of base in the problem at the top and the problem at the bottom, this has taken twice long, which is why we multiply the acid side by 2, because that's what would give you the correct number. If you fail to multiply by 2 at all, that's wrong. If you multiply the 2 on the base side, that's also wrong, because you're still going to get the same number. The idea here is, for every drop of an acid, okay, if this is 1 drop of acid, well, you need 2 drops of acid base. Okay, that's what it really means, right? So this is the 2 math problem I absolutely want you to know, and I think I've asked a few on the homework, a few on the quizzes, and a few through the lab. So stay tuned for one more video in the idea of titrations, and we'll wrap.